Hello and welcome to this video tutorial for Creo Parametric version 3. The content of this video tutorial is importing custom geometry into spline curves. So in terms of making our own custom geometry, you should be well familiar with making simple features in the Creo sketch palette or either importing coordinate systems or data from equations. But the third way we can make geometry is by importing custom points and modifying a spline curve to fit those points. So this is useful for many applications, such as airfoils. So we have a top surface and a bottom surface. Now, with airfoils, accuracy is important. So there's no way that we'd be able to reproduce that by sketching it by hand with simple lines or splines. We're going to have to import some engineering data. So the way I've formatted this is I have two separate sets of data, one for the top surface and one for the bottom surface. And I have this in XYZ coordinates where the Z column is set to 0. So this is for a 2D section that stays within the plane of the page rather. It's important to note that this is a unit airfoil, so it goes from 0 to 1, whether that's a millimeter, a meter, or a kilometer, it doesn't matter. Those units are arbitrary and we can scale them later. But it's important to use a unit airfoil to start with. Another important thing to note is that we always start at 0, 0, 0, and we end at 1, 0, 0. So X varies from 0 to 1. Once we have formatted this data, we then need to save it as a text file. So I've just copied and pasted this from Excel into Notepad, and I've saved it as a points file. So File, Save As, change to All Files, and rename the extension to PTS, points. So Creo knows that there is an X, a Y, and a Z column. So this technique isn't limited to just airfoils. You could input any engineering data to make a surface from. We can close this, and we can open Creo. Okay, so once in Creo, we'll start with a sketch. Now, because this is a unit airfoil, we want to define the chord length. So this is the length from the leading edge to the trailing edge of the airfoil. But to do this, we're going to use construction mode because we don't want these lines to appear on the final extrusion. So I'll make a line. And I'm going to put it at a bit of an angle here. So the overall dimension here will be 1. So we can scale this later, but we have to start at our unit length. And I'm going to change, just turn these data planes off. I'm going to change this angle to 90 degrees. So that will allow me to set an angle of attack later once the spline has been defined. So once we have this set up, we're going to leave construction mode. Now we're going to insert a new coordinate system, and this is what our data will be referenced to. So coordinate system, and we'll just place it there at the origin. Okay. I'll then sketch a spline. This is for the top surface of the airfoil. So we'll start at 0, 0, 0. I'll just put an arbitrary point, and we will end at 1, 0, 0. So that defines our top surface, and I'll do the same for the bottom surface. So it's not a very good looking airfoil, but that's okay. This spline geometry will be modified to the points that we've input from Notepad. So to do that, we double click our top spline and the spline modification dialog box opens. And we want to define this spline from a file. So we have to start by selecting a coordinate system. So this XY coordinate system will be used to refer to the points from Notepad. We want to keep Cartesian. We will open that file and we will import the top section. So we can't import an airfoil at once, we have to import the top and bottom sections. We'll continue. And the initial spline that we made has been reshaped to those points from Notepad. So we can now do the same for the bottom. By double clicking, the dialog box will automatically open. We'll click File, select a coordinate system, open our bottom surface points, our .pts file, import that. It gives us a warning, but that's okay. And we'll just tick OK and let that redraw. So we started by sketching a unit length. We set that to 1. So if we want to set this from 1 mil to say 100, we can now change that quite easily. And if we want to change our angle of attack, we can then set our chord angle from 90 to say 75. So it's an easy way of modifying our airfoil by using construction lines. When we're happy with that, we can choose OK. And the sketch appears here in the workflow. And this just becomes like a normal sketch. So we can extrude, select our sketch, and we can then extrude our airfoil as a solid. Okay, so in summary, we started by importing our known geometry data in XYZ coordinates into Excel. We then formatted those and copied them into Notepad, which was saved as a PTS file. We then entered sketch mode in Creo. We built a top and bottom spline, and we imported that Notepad data into the spline to define the shape.